Today we're going to throw way back and we're going to actually review content from Unit 11 Mastery Check 4, the exponential functions unit. So here we have a word problem, and it says the town manager reports that revenue for a given year is $2.5 million, and the budget director predicts that the revenue will increase by 4% per year. If the director's prediction holds true, we can use the formula y equals 2,500,000 times 1.04 to the power of x to determine how much revenue the town will have available 10 years from the date of the town manager's report. And we're asked how much that revenue will be. Well, 10 years means we need to take that 10 and put it in for x. So the math that we're doing looks like this. And we need to be careful about the order of operations when we put this into our calculator. Remember, we first look to do what's inside parentheses. Well, what's inside the parentheses is just a number, so there's nothing to do there. Then we look to exponents, and we do have one of those. So we need to take the 1.04 and we need to raise it to the power of 10. When you do that in your calculator, you're going to get a really long decimal. It's like 1.48 and then lots of other numbers after that. So you don't want to retype that number. You just want to hit times and then type in your 2,500,000. And we're going to round reasonably because we're talking about money. So we know that we go to the nearest cent when we talk about money. So the revenue that's expected should be approximately $3,700,610.71. Go ahead and try that in your calculator if you weren't doing it along with me, just to make sure you still remember how to push all the buttons in the right order and that things are still working out well for you. All right. We are going to do some factoring practice again today. Now, the instructions say, let's practice factoring by splitting the middle term. And I hope that when you look at the first example, you go, wait, Mrs. Leonard, I don't need to split the middle term in that problem. You are absolutely right. There are already 4 terms in that problem, so there's no reason to split the middle term. But you do need to start by looking out for a GCF. So we're going to do this where we're going to pause, you're going to try a problem, then we'll talk about it, and then we'll pause, you'll try a problem, we'll talk about it. So I want you to try this first one to the best of your ability, and then when you're ready to compare your work to mine, go ahead and play me again, and we can compare our work before we go on to the next one. Okay, I didn't actually finish this problem all the way. I just got to the point where I factored out the GCF. When we have 4 terms like this, we should check and see if we can factor any further, like looking at that binomial and that binomial. Now, when I look at the first 2, I see that they have a 2 in common, but they don't have any of their variables in common. When I look at the second 2, right away, I see that they don't have any numbers in common. So when I go to factor, I'm still going to have a term that starts with 5 and a term that starts with 7. That doesn't match what's in here. So I can tell pretty quickly this thing can't be factored any further. So I'm not going to go through the long process. I'm going to stop right here. The best we can do for this problem is factoring out a GCF. All right, let's look at the second problem. This is a more traditional quadratic trinomial. So we're going to start by creating the puzzle and then factoring by splitting the middle term. Push pause, try it for yourself, and then when you're ready to compare answers with me, go ahead and play. Take a moment to compare the steps of my work to the steps of yours. In just a second, I'm going to reveal the other way. So if you notice that you reverse the order of the 7x and the negative 10x, then hold on just a minute and your answer is going to pop up in green. And now you can see how it would look if you did it by reversing the middle 2 terms instead. We get the exact same 2 binomials, just in the opposite order. All right, one last problem for today. And again, I want you to try it before I show you my work. So take a look at this one. Give it a start. Push pause on me. When you've made it all the way through, compare your work to mine. This is the way we've been doing these problems all along. When we notice that we have a quadratic and then a constant, so a term with a square and then a term with no variable, we put the 0x in the middle and then proceed as normal to factor by splitting the middle term. But you might remember that on our last notes day, I actually taught you about the thing called difference of squares. So I want to show you how I actually factor this one when I'm all by myself and not showing somebody how to split the middle term. When I see x squared minus 144, I immediately notice that I've got a square minus a perfect square. And I say to myself, okay, the square root of x squared equals x. And the square root of 144 equals 12. So then I remember my pattern. Remember the pattern was a squared minus b squared equals a minus b times a plus b. Well, the x is the a and the 12 is the b. And all that work that I just wrote down for you, I do that in my head because I've done these so many times I don't have to think them through anymore. And eventually, when you get through Algebra 2, you're going to do it in your head too. And I just look at this and I go, oh, that's a difference of squares. And I write down x minus 12, x plus 12, and that's the only work I do. So that's the power of recognizing that difference of squares formula. Now, if you get good at factoring with difference of squares formula this year, that's awesome. All you have to write for your work would be this, and then you would just write the words difference of squares so that I know you did this with the pattern. So that is an option if this is a pattern that makes a lot of sense to you. No homework tonight. We're all done our little sheet. Talk to you tomorrow.